Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 117 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons, and in this class we will be using the Kepler kit for Raspberry Pi Pico W. Now hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to do is I'm going to teach you how we can control a DC motor remotely over Wi-Fi using PyQt and UDP, okay? And really today's lesson is sort of a culmination of a lot of things that we've learned in the last few weeks. Like we learned how to exchange data between a client and a server over Wi-Fi using UDP. And then we learned how to build graphical widgets using PyQt. And then we also learned how to run the DC motor last week. So this is really beginning to bring together a lot of learning that we've done over the last few weeks. I guess I should ask, how many of you guys were successful in doing the homework from last week, which was to put this project together? If you were successful, leave a comment down below. I am legend. Double chest bump. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair, but hopefully you guys were able to do it. There might have been a few surprises in there along the way. We can have some challenges with electrical noise when we're dealing with a DC motor. And also there's a tendency with these little DC motors, we can pull down our DC power supplies. And so hopefully those didn't turn out to be too big of a barrier for you. But in any case, never fear, because I will show you my solution today. Okay, so let's get started. Let's get our circuit set up. I believe this is the same circuit that we used last week. So you can come to the most excellent www.toptechboy.com and you're going to search on something like control DC motor with Raspberry Pi Pico W in the most excellent TA6586. You come here and then you will find this schematic, okay? And this schematic shows you that we are using the power board, the breadboard power bank from Sunfounder. Unfortunately, this component came out after the Kepler kits were released, and so this is not in your kit, but I've got a link down below. You can hop on over there and get your power bank. I think they're under 10 bucks, and they're very, very useful little devices. It actually has a battery on it, so when you plug this thing in, you can run your projects. When you plug this thing in, you can run your projects remotely. Because as I've got it configured here, it runs not only the motor and the TA6586, it also runs the Raspberry Pi Pico W. So after you get your server code down in the Pico W, you can just unhook and you can run around your house with this, okay? I hope that sounds good. So that's how we are going to hook it up. And then the other thing that we're going to do is you'll want to stay on this page because some of this motor code from last week is kind of useful and it'll help us with some commands so that we don't have to type every single thing in from scratch this week. Also, what we're going to start with is, remember a few weeks ago we did this class sending data over Wi-Fi between the Raspberry Pi Pico W and your PC. And so I think you'll want to go to that page and ignore the circuit there, but there's some nice software for setting up a server. There's some nice software for setting up a server, and then there's some nice software here for setting up a client. And I think that that's a pretty good. I think that that is a pretty good place to start. So I think that we'll start with that. We'll start with that. That client server relationship, and then we will tweak it for our particular motor application. Okay, so let's see. I think what we're going to do is we're going to start by getting a couple of fresh Thonny windows up here, and I need to go ahead and close out of the stuff that I was doing. I'm going to close out of the stuff that I was doing, and then I'm going to open a new window here and a new window here. Remember, we had some trouble earlier on if we tried to, have one instance of Thonny running the server side and the client side at the same time. So I've got two different windows, and over here we are going to do the server. And so this over here we will need to see if I can, I've kind of got my view block down here, but down in the bottom I want to connect this one on the right to the Raspberry Pi Pico W, and then this one on the left I want to hook to local Python. So on the left we're going to be doing the client on the PC, and on the right we're going to be doing the server, which is going to be on the Raspberry Pi Pico W. So let's come on over there back to www.toptechboy.com. Okay, and this was that sending data over Wi-Fi, and then this is the server code, and we're going to go ahead and get the server code because it's got all those little quirky things already put in there, and so it'll make it kind of easy. Just notice that we are importing secrets, and that's where you put the name of your Wi-Fi, and that's where you put your Wi-Fi password. And so you will need to, on your Raspberry Pi Pico W, in the lib folder, have a file called secrets.py, and it needs to be these two lines of code where you put right here in the quotes your Wi-Fi name, and then right here in the quotes your password name, and then you save that to the Pico W, and you save it as secrets.py, but you import it as secrets up here. Okay, of course, we've already got that done if you've taken the last few lessons, but I'm going to take this code and I'm going to come over here on the server side. Okay, and then I think I need to get further out of your way when I'm over here, but let's just run this thing, and this just generates some, arbitrary data, and let's just see if it'll come up. Okay, what's the good news? It comes up, it says that it is connected to the Wi-Fi. It gives me my IP address. No, this is the IP address. Okay, and this is the IP address, and now it is waiting for the client to ask for something. So I'm up and connected to Wi-Fi, and that, my friend, is usually about half the battle. But now, instead of just grabbing a command and then sending a command back, like listening, hearing, and then sending something back, this is just kind of sending, it's not really doing anything other than establishing the connection. And so what we're going to need to do is we're going to need to get some of that, we're going to need to try to get some of that motor code, because what's the server doing? It is going to be controlling the motor. And so I think up here at the top, we need to get that code that connects, and this is right. The two motor connections are on pin 14 and 15 in the schematic. But we're going to come back to toptechboy.com. Okay, we're going to come back to toptechboy.com, and we're going to go to that motor software that I did last week. And do you see the kind of cool thing here is it did all of the setting up the pins and setting up the PWM. Right? It set up the pins, set up the PWM, and set up the frequency. So let's just snag that to save ourselves a little bit of time. And that's going to come over here on the server side, and that is going to define the pins, set up the PWM, and set up the PWM frequency. And so that is going to be pretty useful. And then what are we going to want to do? What are we going to want to do? We're going to want to set up the WLAN. And so that gets set up. Okay, then we're connected. Then we are going to set up our socket. Okay, and our socket is going to get set up, and that is pretty good. Okay, and then we're going to go ahead and we get it bound, right? We get it bound, and then we say server is up and listening. And just once more for fun, I don't think we need to print out our IP address again, because when we do up here, I think we printed it out, didn't we? Let's see. Let me run this again and see if it's still printing out. Whoop, pin is not defined. Yes. So what do we also need to do? We're going to need to do we're going to need to do a from machine import. We're going to need pin and PWM like that. So now let's try to run this. Let's just see where we are. Yeah, so it gave us the IP address right here. So you'll need to make note of that. So I just took that thing out so I'm not printing it out more than once. Okay, now we come up here and we say we're all connected. We're all connected. And now the last thing that we did was we said that we were waiting for the client. Now, why does it appear that the program stops there? Because there's no client and nobody's sending commands. So it's just doing what we need it to do, and what we need it to do is to sit and wait for a command. But now when a command comes, we're going to get the command here. When the client contacts us, we will get the command that he sends in request, and then we will get his address in client address. Okay, and then what we want to do is, I think that I'm going to take okay, so what I'm going to do is, once I have that request, I'm going to go ahead and decode the requests, because right, the request has some strange characters on it and some unexpected things. So I'm just going to say request is going to be equal to request.decode, like that. Okay, and then here when I print what he has requested, then I can just go ahead and print request now, because it has been cleaned up, and then I see who it'll print out, who that request came from. All right, now what is the request going to be? Let's get back to the real world. What are we doing? We have a motor, and we want to be able to set the speed and the direction of that motor from the client side, and specifically PyQt running on the client side. So I got to kind of figure out, what do I need in order to do that? Well, in this command will be built on the client side, but what it's going to have is, it's going to have a single letter, a string. It's going to have an F for forward, an R uppercase for reverse, or an O uppercase for off. So it's going to be F, R, or O. That's going to be the first part of the data packet. And then there's going to be a comma. And then there is going to be a number, which is going to be the speed of the motor. So you're going to say what direction, and then you're going to say what speed do you want. Okay, so how am I going to do that? So that means that what's coming in, a letter, a comma, and a number. So what I'm going to have to do is, I'm going to have to create the array, because something comma something, you can make that an array. So I'm going to say that's my command array. And then how am I going to do that? I'm going to take the request, which has been cleaned up, and then what I'm going to do is I'm going to split it at the comma. So instead of having like F comma 37, it is now going to be an array. The first element is going to be the string letter F, and the second element is going to be an integer, or it's going to be a number. Okay, so now I have that array. Well, what do I want? I want to know the motor state, like, what do you want me to do with the motor? Do you want it to go forwards? Do you want it to go backwards? Do you want it to go, do you want it to turn off? So I'm going to have the motor state, and that is going to be command array that I just that I just generated, and it's going to be the 0th element. So that's going to be where that letter is, and that's the motor state. Then I'm also going to have the speed, and that is going to be command array of element 1. So that would be the number like 123. But remember, the whole thing gets passed over as a string, and then when I make it into an array, I've got the string, say, F, and then I've got the string, say, 123. So the 123 comes over when it's split as a string. So I better darn well turn that into a number by saying take the integer value of that string, and now we should be all good to go. Okay, now what I want to do is that we're thinking now I've got a number, right? I've kind of been sent something, so it wants me to update. But what I think that I probably what I want to do is I want to go ahead and turn the motor off. So I'm going to do an rpwm.duty, and that is the reverse pin, and that is an underscore, a unsigned int u16. Okay, and I'm going to set the duty cycle to 0 like that. And then I'm also going to get this, and I'm going to make that forward pin, right? And this is the, you remember, what was it, like pin 14 and 15, I think. We set it up here at the top. Yeah, it's pin 14 and 15. And you've got the forward pin and you've got the reverse pin. And I want to set them both to 0 up here, okay? And then what I'm going to do, I think I'm going to go ahead and say a time.sleep of 1. So whatever I do in the next code, I'm not going to have the possibility of going full speed forward and instantaneously go full speed back. Anytime I get a request, I'm going to slow this thing down. But we'll have to see when I run this thing. We'll have to see if that's really what we're going to want to do. I think for right now we'll leave it out, and then we will take care of that somewhere else. But we will set everything to 0. Okay, we'll turn the motor off. Now we got to decide, what is he asking me to do? Well, if motor state that was sent to me, if that equal off for uppercase O, not 0, uppercase O, if I've sent an O, what do I want to do? I want to set everything to off, right? I'm going to set everything to off. And I think just to help me debug, I'm going to just go ahead and I'm going to print, okay, I'm going to print the, what I got in was to do an O. And sometimes doing this just helps you debug, all right? And then, okay, we'll put debugging in if we need it, but right now I'm not going to put the debugging in. So now, what are the other possibilities? Okay, the other possibilities are if the motor state is I'm having trouble finding that, F. What do we do if the motor state is F? Well, the reverse PWM is still 0, but now the forward, and this really should have been forward, right? So I do reverse forward, and I do reverse forward, and I do, okay, so now this time I do the reverse, and the forward now I want a value. Okay, if we just wanted to turn it on, we could, put this, we could put this at full blast. But what we want is, we want the speed that we were passed, and then we want to divide that speed by 100, right? Because we're going to have a speed from 0 to 100. It's sort of like 0% to 100%. So you take the speed divided by 100, that's the percentage. And then we've got to multiply it by that scale factor for PWM. Well, what's full scale PWM? 65, 5, 35. So if I have 100%, I'm going to apply a duty cycle of 100 divided by 100, which is 1 times 65,535, which is going to be 100% duty cycle. And go back and watch some of my videos on PWM if I just confused you. Okay, but now even though speed is an int, 100 speed divided by 100 is going to be a float, and then that times 6535 is going to be a float. So even though I'm passing it an int, speed, the int divided by 100, it's going to turn itself into a float, and this duty cycle wants an int, so I'm going to have to turn it into an int again. Does that make sense? Okay, now what is the other one we need to do? We need to do reverse, and it's probably very similar to this one. Okay, so what we're going to do is here, what happens if it is reverse? Well, in that case, I want the forward, the F, to be 0, and I want the R to be this. And then I think that should work. Let's go ahead and run this and just see if we put some errors in there. Okay, we don't know if this is really working, but what we know is we're looking for a request from the client. We parse the request all up, right? We parse the request all up. And now we probably need to send a response back. Well, this was just creating fake data, so we don't need to create fake data. But what we can do is we can say the data that we're going to send back is equal to the request that was sent to us. Why do we do that? Just let Joe know if he says, hey, I want an orange. We say, yeah, here's your orange. So we're just letting the client see that we actually got what he asked and we didn't mess up somewhere along the way. And then we can say that request CMD for command has been processed. Okay, so that's our data. Then what we're going to do is we're going to send that data back to the client, and then we're just going to print out that we had sent that. We're going to print out that we had sent that. Okay, and then we don't need a time.sleep here because really things are going to be handled over on the client side. Things will be handled on the client side. The timing. Okay. So let's just make sure at this point that this runs. So we're going to run it. Okay, so that looks good. Now just remember, before this is over with, we're going to be wanting to disconnect the USB cable, and we're going to want to be running remotely. And so we ought to, just for good measure, go ahead and save this on the, Stop. We're going to save this on the Raspberry Pi Pico W, save as. We're going to save it on the Raspberry Pi Pico W as main.py, and that way it'll run just when the Pi Pico is powered up, even if there's no USB cable to it. Okay, so we got all that good stuff done. Now we got to come over to the client side. So let's go see if we can get that client software, just because it does some of the tedious stuff for us. We're going to come back, and we're going to come back to this sending data over Wi-Fi between the Raspberry Pi Pico W and your PC. And then remember, we had the client here, we had the server here, and we come down to the client code, and let's go ahead and get that client code. And now we're going to come over to the client side, and I don't think I can really run this, because what is this doing? This is just sort of saying, hey, I got your message. That's all it's really saying, is I got your message. Now, one thing I got to do is let's make sure that we're using the right IP address here. So over here on the server side, I'm going to run it, and then you can see my IP address is not the same as it was before. It's this first one. This is like your router IP address, and this is your gateway and stuff like that. But this is the one I want. This is my Pico IP address. I want to copy that, and I want to come over here, and I want to put that in. So that will be good. Okay. So now we need to go over to our client. We need to go over to our client. And a couple of things that we're going to need up here. We imported the socket, we imported time. Let's go ahead and say from PyQt 5.qt widgets import everything, and from PyQt 5.qt core, we're going to import everything. And then we're going to import sys, because remember there's that one command that uses the sys methods. Now I'm going to go ahead and set up, I'm going to need some variables. Speed F is speed forward. We're going to start with a forward speed of 0. Our speed reverse is going to be equal to 0. And then our motor status is equal to, in quotes, uppercase letter O. Uppercase letter O. Okay, now, so we're going to try to see if we can send we're going to try to see if we can send a motor command over here. We're going to see if we can send a motor command over here in a second. And so before I start talking about the Qt widget and how we're going to build a graphical interface, I'm wondering if there is a way that we could just send something over there. Like if we come down here, I think we've got things set up, and then it's a send to request message, and then somewhere up here we probably set up a, okay, so our request message was kind of what I'm going to call this is, I'm going to call this our command. Okay, and then I'm just going to make the command equal to, let's just say F, and then comma, and then let's say 25. So that would be running very, very slowly. And then what I'm going to do is I'm going to send that, which is going to be CMD. I'm going to send that to the server, and then I should get the response back. And then I'll just do that every 10 seconds. I want to just see if I can send a simple little created command over and make the motor run. Okay, I'm going to see if I can just send something really simple and make the motor run. So this is what it's looking like. And I'm going to come over here, and then I'm going to make sure that I am connected to Python 3 on this side. And then let's run this, and no module called PyQt 5. Did I put a typo in there? That was in line 3. How could I make a mistake on line 3? Okay, so now let's try it. Okay, boom. Do you see that? Okay, so let's turn this off, and let's stop that. Okay, so what do we know at this point? What we know is that we have a connection that's working, right? We got a client-server relationship that is working, and we can send a simple command that will turn the motor on. And so that is really, really, really good. So now at this point, what we want to do is we want to start building our graphical user interface. So we're going to create a window. Inside that window will be our main layout. And the main layout is going to lay things out horizontally. And then inside the main layout, I'm going to have two layouts, the left layout box and the right layout box. The left layout box is going to be vertical. Okay, it's going to be a vertical box, and it's going to have a vertical slider bar for forward speed and a vertical slider bar for reverse speed. So window, main layout, left layout is going to have widget slider bar forward, widget slider bar reverse. Then I'm going to have the right layout, and it's going to have three buttons. The go button, which is going to be green, the reverse button, which is going to be blue, and then the stop button that's going to be red. So the green button makes it go forward at what speed? At motor speed. The forward motor speed. Then the blue button is going to make it go reverse in the reverse motor speed, and then off is off. Forward motor speed comes from the first slider bar. Reverse motor speed comes from the bottom slider bar. Okay. Boy, I talked fast there, didn't I? Stop back up, listen again, and make notes. But that's what we're going to do. So what we're going to do here is before we really do anything, and we're just going to leave this down here because we're going to need some of those commands, right? Some of these commands will help us in a minute. But after we set up this server, we need to start setting up our widget, okay? So my app is going to be Q application, and we're going to run the system argv, which doesn't make any sense, but it's got to be there. Now we're going to create our window, okay? Our window is going to be a what? A Q widget, like that. Okay, so we got the main window, right? Now the window title is going to be set window title, like that. Set window title. Now what do we want our GUI window to be called? I'm going to call mine the Big Boss Motor Controller. I kind of like that. See if you guys can come up with a better title than that. But if not, that is a great title. Okay. Now, so what do I have? I have my window created. Okay, I have my window created. And I'm just kind of checking. Let me just check a few things here. Just trying to see. I'm trying to think exactly what to do up here. It's just these widgets are so much easier if we kind of do them in a methodical way. So now I have a window, okay, and that window has a title. I have a window and that window has a title. Now the window, we need to say how big it is. So the set geometry, I want it 100 pixels over from the upper left corner and 100 pixels down. And then I want it to be 800 pixels wide and I want it to be 600 pixels tall. All right. Now I'm also going to have a main layout. Okay. And that is going to be a horizontal layout because, right, I want my left layout here and I want my right layout here, and they will be in main layout. So main layout needs to be horizontal. So it's packing my other things left and right. So Q horizontal, and it's going to be a box layout in the window. Okay, so what do I have now? I have the main layout of the window, the main layout of the window. Now I'm going to need that left layout, and that's going to be Q. And now the left layout is going to be a vertical box layout. Why? Because I want the slider widgets on top of it. So it sits horizontally in the main layout, but inside it, I want things to be vertical. So that's going to be a vertical layout. And then the right layout is equal to another one, QV box layout, like that. Okay, now why am I doing it like that? Because I think that it's good to sort of create your layout boxes at the top, and then as you go down and build widgets, you can put them in the right place. And then at the very end, then we'll kind of stack these things together. So everything's going to happen in the middle, but let's see if we can go ahead and kind of get this all taken care of. So what do I have? I have my main layout. My main layout is going to have in it the left layout, right? So I created this left layout. Where does it go? It goes into the main layout. And what do I need to do? I need to say dot add layout. So I'm adding to the main layout the left layout. I'm going to main layout, add layout, the what? The right layout. Now I'll put widgets. I'll put widgets inside of left layout and right layout. As we build the widgets, we'll add them to the little layout boxes. But here we're getting the overall structure to fit together. Well, for the window, which is the main thing, we need to set the layout for the whole window, which is going to be what? The main layout. So you see, I kind of said the main layout's going to have left, the main layout's going to have right, and then the overall window is going to use the main layout. So I have window, I have main layout, and then I have left and right layout. So you see left box, right box layout. So you see it's kind of like 3 levels of nesting there, right? You can kind of see that there are 3 levels of nesting. Okay, and then our most likely to forget and most hard to debug is the window.show. You can spend hours wondering why you didn't get a window. And then we need to shut things down with sys.exit app.exec underscore open close like that. Okay. And then close that. Okay, now I'm trying to think. I really want to run this thing pretty quickly. And so I think that really what I need here is I'm cleaning up all this stuff down here. We're going to build real commands, okay? And so I'm not going to have this while true. And these commands that I'm going to need in a minute, I'm just going to comment them out. Okay, those are the little things to send to, talk over UDP. But let's just see, we're not going to be talking over UDP, but let's just see if we can run this thing. Okay, right layout is not defined in line 24. What is this? Right layout. Did I misspell that out here? Right layout, like that. Okay, now let's run it. Okay. And then this is an error exec. So let's try it again. Okay, no errors. And I've got my window, big boss motor controller, and then I have a left layout box and a right layout box. Why is there not anything? I've got the framework, I've got the skeleton of the program, but what have we not done? We haven't built any widgets and we haven't put any widgets in there, but it's kind of like the overall structure is working. And I really want to be adding things as we go. I really want to be adding things as we go and running it and making sure that I'm not breaking anything, okay? So now we have all of that done, okay? So we got all the way here is now where all the action's going to happen here in the middle, okay, here in the middle. And so what is the first thing that I want to do? Well, I'm going to create my slider label. So I'm going to create my slider label for the F, for the forward direction, and that's going to be Q label, and then I'm going to label that what? Forward speed. So when I build that slider bar, it's going to have a label, and that label is going to say forward speed. Okay. Now I'm going to go ahead and label F, and I'm going to set the style sheet for that label, and I want a font size of 20px, right, like that. And then you've got to have that awkward trailing semicolon there. It's like we're back on Arduino land or something. Okay, now I built that. So what do I want to do to the left layout? I want to add this widget. And which widget? What I just created, slider label F. Now, if we are lucky, we could run this and we would actually get our first little thing in the box, which is just going to be the label. Q label is not defined. What is that? What is that? Their nomenclature for their font is not exactly like the way I do it, and that I consider to be very, very confusing. Okay. And so we come over here, and now let's try running it. Q label set style sheet. Man, I am typing like a crazy man. Style sheet. Okay. Man, okay, I promise I am going to slow down. I'm going to slow down and type more carefully. Slider label F. Okay, now look at this. You don't see lines around the layout boxes, but you can see I have forward speed, and that's the only thing that's been added to it. So that's good, right? That is good. So I have the label, but now after the label, what do I want? I want the slider. So I'm going to create slider F for the forward direction, and that is Q slider. And then what type of slider do I want? I want it a vertical slider. So it is going to be qt.vertical, like that. And now I'm going to have the slider F and the set minimum. I'm going to set it at 0, meaning if I set minimum speed, it's going to be stopped. And then I'm going to have slider F, and I'm going to have set maximum, and the maximum is going to be 100. And then I'm going to have slider F set value. Where do I want it to begin with? 0. So when you run the program, then this will be 0 and the motor will be off. Okay, the motor will be off. Okay, now what do I do? What do I do if I set it, if I click it or move it? Slider F, if the value is changed, you're going to connect to what function? The update for speed function, like that. Okay, now if I'm going to do that, I'm going to have to come up here and I'm going to have to put that in. And so where would be a good place to put it in after I set up all the widget stuff there? Then what I'm going to go ahead and do is say define update for speed, like that. Okay. Now, update for speed is going to be very easy. I need to make a global variable of speed F so the other functions will know what speed was set here. And then when you update that slider bar, it's going to pass a parameter to your callback function. I'm going to capture that parameter in value. And then all I'm going to do is say speed F is equal to value. That's where the slider bar was set. And now I'm going to print it just to help see if we know what we're doing, speed F. Okay? Does that look good? I think that's good. Do you think we can run this? I don't know what's going to happen. Line 33, slider F is not defined. What is this line 33? Now that is oscilloscope. That really looked right to a dyslexic person, which I am. So now let's run this. Okay, so that looks good, right? We didn't get any errors. What did we not do? We didn't put it in our, okay, so, all right, well, that's okay. So it's just we got that much done. Now, what do? We run that. Now what I need to do is I'm going to put some formatting on here. Slider F, I'm going to set style sheet. Okay, and I will be honest with you, I hate these commands like this because they're not very intuitive. Okay, what am I going to set? We are dealing with a Q slider. And make note the S is uppercase. Colon. I'm talking about the handle, right? And it is a vertical slider bar. So I've got a Q slider with a handle, and the slider bar itself is vertical. All right. Now, open curly. I want the background dash color colon, and that's going to be RGB, and it's going to be 0, 255, 0, 255, 0. So I'm going to set that slider bar to what? To green, okay, to go with the green go button. You see we're getting a little matching of colors here. Now that has to be followed by the dangling semicolon. We got to close our curly. We have to close our quote, and then I've got to close the parenthesis. So make sure you get that. You've got the dangling semicolon, the closed curly, close quote, and then close parenthesis. All right. Now before I run it again, so we've created the widget. Where do we want to put the widget? We want to put the left layout, just like the label. We're going to add the widget, and then what are we going to add? The slider forward. Okay. Now with a little luck, that's going to give us a slider bar. Okay. So let's see here. All right. Okay, there is our slider bar. It is green, and then we can adjust it. And then you see as we adjust it, this is working. Now, why is it in the middle? Because I haven't put the right layout box, I haven't put anything in there, and I haven't put the other slider in. So it's just kind of putting things, it's centering everything until we get those other parts in there. But man, we are on a roll, ladies and gentlemen, we are on a roll. Okay, now what do we need to do? I think we need to do almost that same thing. All of this, we're going to create a new label and a new slider bar. So we are going to copy all of this, and then we're going to come down here and we're going to paste it. And now let's go make it our own for not the slider F, okay, but this is going to be the slider reverse, and this is going to be the slider label reverse. And then we're going to add widget to what? We're going to add what? The R, the reverse. And then similarly here, this is R, 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 and then we're adding R. And then all of these, I think, are the same. Now we got to look up here, slider label R. Yep. Okay, that all looks good. But this one for the reverse, we want to be blue. So we're going to come over here and make the color 0, 0, 255, because, right, it all goes RGB and R and G and B, and it's a number between 0 and 255. So 0, 0, 255 is going to be full on blue. Okay, so now let's run this, and hopefully we'll get 2 slider bars this time. Okay, look at that. So you see I've got that, like that, and then this one. Okay, you see, man, we are on our way here, and we haven't had any really terribly difficult errors yet, have we? Now, the one thing I think I would need to make sure is that the update for speed, I think, yeah, the one thing I've got to do is the reverse, though. I need to have an update reverse speed, right? And then I've got to do a new function up here. So you see the speeds are going to be different in the 2 directions. So I've got to have the update for the forward speed and the update for the reverse speed. And this is going to be the speed reverse R, and then speed R, and then speed R. And so that time both slider bars were updating the same variable, which you don't want to do. You want to have each one have its own variable. Okay, so now what do we need to do now? Now I think what we need to do is we need to go in and we need to put our buttons in. Okay, so I'm going to come down after my slider right? So I got that. And before I kind of wrap things up, I'm going to work on my buttons. Okay, and so I'm going to have a green button is going to be equal to a Q push button. And then what is the label going to be? This is going to be my go button. Okay. And then I'm going to have a blue button. And I think that it would be wise for me to copy here. So I'm going to copy. I need how many buttons? 3. So I'm going to V and Control V. And so the green push button, then I'm going to have the blue push button is going to, the green is going to be go. The blue is going to be reverse. And then the red is going to what? It's going to turn this thing off. And so this will be stop like that. So I got 3 buttons, right? That's pretty good. Now, what do I do if the green button is clicked? I'm going to connect to what? Motor go, like that. Now, what is motor go going to do? That's going to have to be a function up here. So I did the update reverse speed. Now what I'm going to do is I'm going to define the motor go when we get our motor running, right? And then we're going to have a global, the motor status. Okay, now we've got the speed. We know the speed, fast, slow, in between, but the question is, what do you want the motor to be doing? So we've got the motor status. And here, if you press the go button, you want the motor status to be equal to what? F, it's that letter, right? And then I'm going to print what this function does, which is this has gotten to the go. All right. So there. Now let's just, and then what do I need to do? I'll come back down. I'll come back down to, I was playing with this button. What do I do when I click it? Okay. And then what I'm going to do is I'm going to write layout.add widget, right? The right layout is that box on the right. I'm going to add widget. And what I'm going to add, I'm going to add the green button. Like that. Okay, so now let's see what happens with all this. Okay, look at this. All right, so I've got my forward speed. I've got my reverse speed. And if I press the go button, it goes up there to the go. Okay, so that is pretty good. That is pretty good. Now there's one thing that I still need to do, and that is that button was not very pretty, was it? So I've got my green button. I've got my green button created. And then when I create my green button, I'm going to have a green button dot set style sheet. And what's it going to be? I want a background dash color, and I want it to be an RGB color. And I want that RGB color, the green should be green, so that would be 0,255, 0, right? So I got to set that color. Now, I don't want, so I set the color. Good. Semicolon. Now the border radius, if I set that to 50 pixels, what is that going to do? That's going to round that and make it not a square button, but a rounded corner button, which will look better. Now I want a minimum height. I want a minimum height, colon, of 100 px, 100 pixels. So you see minimum height. What is the minimum height? You put a colon. Then the separator between the parameters is the semicolon. And if you kind of see that, it sort of makes it easier. So I've got the minimum height is 100 pixels, and then I'm going to put in a font size of 20 pixels. And then I'm going to put in a color of white for the text. A color of white for the text. Now, you have that dangling semicolon. You close the quote, and then you close that. Now, hopefully this will come up with a formatted button, right? Hopefully this will come up with a formatted button. So let's write this. Let's run this. Okay, look at that. I got a great big green go button, and it's alive, and then that matches that and that, and that looks pretty good. I'm just wondering if that was pretty bright, so I think I might try black here. On that one, it might show up best as black. Let's see. Yeah, I think that's more readable. Okay, so that's good. That's good. So what do I need to do? So I've got that button. I'm going to just steal the style sheet because that was kind of hard to type in, right? That was kind of hard to type in. So I'm going to steal that style sheet. And then I'm going to add that style sheet to the blue button. And I'm going to add that style sheet to the red button. And then I think all I need to do is probably change the color. So this one being I did green button. This one is going to be the blue button. And this one's going to be the red button. And so the blue button we would want to make blue. So that would be 0, 0 to 55, and this would be red, which would be 255, 0, 0. Okay, now we did for the green, we went to motor go and we added it to the layout. But now we need to do these two things for the other two buttons, right? So I'll paste it and I'll paste it. Now, what do I want to do? That's the green button. This is the blue button, and we will want to put blue button on the right layout. And then instead of motor go, what are we going to do? We're going to do for the blue motor reverse. Now we got to come up and define that function, which will be very easy because we'll take this and we'll paste it. And then this is motor reverse. And in that case, we want this to become, instead of forward, we want it to become reverse. And then here we'll print REV. Okay, so that's good. We'll come back to where we were. And so we have taken care of motor go. We've taken care of motor reverse, the blue button. And now we're going to have the red button is going to go to motor stop. And then we're going to add to the layout the red button. Okay, now we'll come back up here and we've got to add that motor stop, which will be exactly like this. Okay, so this is going to be motor stop, and then here we will print stop. I think I'm doing better on this widget than that one that we did last time. I'm trying to be much more methodical in the way that I'm doing this. Okay, so look at this. We have go gives us go, reverse gives us reverse, stop gives us stop, and then I can adjust the forward speed. I can adjust the reverse speed. You see, I've got all the functionality that I want here. I really got all the functionality that I want. And so that is very good. I didn't like on that blue button, I didn't like that black on blue. It didn't show up very well. So let's go to the blue button style sheet and all the way over here. Let's go back to white. Okay. I think white on blue will show better. Okay, so now those update everything, right? Those update everything. So what do I really need now? I just need to take all that updated. Anytime I adjust forward speed, it adjusts the forward speed parameter. Anytime I adjust the reverse speed, it adjusts that parameter. And then I can say go forward, go backwards, or stop. So anywhere I should have the most up-to-date parameters for the command. But now I just have to periodically go and send that command in. And so what I'm going to need here is I'm going to need to set up a timer, and that's going to be a Q timer. And then it's going to do a timer dot time out, and it's going to connect to where I'm going to update the motor. Right? Update motor is going to send all that data to the server, right? It's going to send all the data to the server. I haven't defined it yet, but patience. We'll get up there and we'll define it. Don't you worry. Okay. And then I'm just going to say time.start, like how often do I want to interrupt? Let's say every 200 milliseconds, which kind of means 5 times a second, we'll be updating that. Now, if I'm going to define that, if I'm going to call it, I better go up and I better define it. Okay. And so let's make it the first one that we do up here. Our first function is going to be define our update motor, like that. And what's the first thing? Well, we better have as global, we better have motor status. Okay, we better have motor status. And then I think we better, to be safe, we better have speed F and we better have speed R, right? To make sure that the speed F and the speed R that are set, you know, where did we do that? Oh yeah. This speed R is going to really be a global in that it doesn't make this a local. So I think this is really the best way that we're going to do this. Okay, now what we got to see is that what we got to see is I am going to be sending a command to the server. And if for some reason the server hasn't turned on yet, or if for some reason the server got confused about something, I don't want the program to die. So I'm going to do this all in a try and an except. So I'm going to try to do it, but if it doesn't work, I'm going to say print server did not respond. Try again, like that. Okay. Now I probably am going to need to set a server timeout so that it will only wait for so long. So up here where I do the client socket, after I make the client socket, I'm going to set a client socket dot set timeout of 1 second. So if you ask the server for something and you don't hear back in a second, it will error out and it'll come back here, and then it will come back and it will try again. Okay. So now what do we want to do? Well, let's just print the motor status just so that we can see where we are. Okay. Now what are the motor status? Well, if motor status equal F, I want to generate that command. Well, then what will my command be if it is F? Well, it is going to need to be CMD. And remember, CMD is what I'm going to be sending to the server. It's what the server is waiting for. And what did it do? What did it want? It wanted a letter, which is going to be motor status, concatenated with the concatenated motor status, concatenated with a comma, and then concatenated with the string of speed F. Right now, why is that? Because remember, we're sending this as a string, a letter, a comma, and a number, but that number, it's all sent as a string. Okay, so now that is for that case. Now, what is the other case that we are going to do? We are going to do a Control C, and then the other case would be, what if we want a reverse? Well, in that case, we would still send motor status, but we would send the reverse speed. And those other functions are all keeping this data up to date. So all we're doing here really is just building the command string. What was the other one? Uppercase letter O. And then what do we do there? Well, motor status, and then also certainly that would just be the 0, not an O, the 0. Okay, now what do we need to do? We need to send that over to the server. So I think we had those two commands down here. And so I think all of this stuff is going to be very useful. We don't need that fake command, but we're going to get these that we had. And then we're going to come up here. Okay. And we're going to paste them. And then we're going to uncomment them. Uncomment. Okay. And these should be all under the try. Okay, so what are we going to send? We are going to send the CMD and we're going to encode it, and then we are going to print what the response is back. Wow. That's a lot of stuff that we just did, wasn't it? I wonder how many mistakes we made, but let's take a deep breath. Let's have a sip of coffee. Let's be patient. I'm going to give myself a little more room to see the errors. Let's come over here and see what's happening. Now, you know, guys, what I'm going to do is I'm going to, the server data is already in there. And so I'm going to disconnect this from the server. And then I'm going to turn the power bank on. And so now the server is coming to life and it should be running that main.py. And so now what I will do is I'm going to run the client, and let's just see if we get a box up here. What server did not respond? Try again. Okay, yeah, I didn't close that. Where was that? Right, I didn't close that print that I just did. Or I opened it one way and I closed it a different way. You can do one or the other, but don't do both. Let me show you that. Okay, right, I had an error right here and it said server did not respond. I had a single quote here and a double quote here, so you need those to be the same. So then let's run this. Start has no, what is that? Inline 106. That was not smart. That is time that I created. I created time. So let's try that. Okay, now look at this. The good thing is here, you can see that the server is responding. And why is the motor not running? The motor is not running because we started it in the off position. So what if we said, let's start a forward speed of about 23, and now let's say go. And when we do that, boom, the motor came on. Now let's say stop. Okay, server did not respond, so I've lost connection with the server. I have lost connection with the server. So Houston, we have a problem. Okay, and so let's turn this off and let's turn this back on. So we turned it off and we turned it back on. And now let's try running it again. I mean, the good news is I'm talking to the server. The good news is it's trying to respond. Let's say if I come back here, and now let's say, where was I? I'm going to go to about 30, and now I say go, it starts, and then all of a sudden, as soon as the motor starts, I lose the connection. So there's two things that could be going on. There's two things that could be going on. One is that I could be generating noise. I could be generating noise because of the motor. And so let's check that. I think I can check that by coming over and, you never have a little wire when you need one, but I'm just going to come over and I'm going to connect to the power rail. Okay, I'm going to connect to the power rail with my oscilloscope. Okay, so now when I turn this on, the oscilloscope should come on and I should see like a 5-volt signal. Okay, so watch the scope. I turn this on and I don't see a 5-volt signal. Why do I not see a 5-volt signal? And the thing, oh my, it was running already. Okay, so I'm going to stop, turn it off. Okay. So I'm expecting to see a 5-volt signal here when I turn this on, and I'm not sure why. Oh, there it is. Okay. So do you see what we see here? We see a 5-volt signal when that comes on. Now I'm going to run this. I'm going to run the client, and then still I'm seeing a 5-volt signal. So all that looks good. But now let's set a forward speed and let's turn it on. And now for some reason, there it is. Okay. Now what is the problem? What happens when I turn that on? I'm getting a huge noise signal. I'm getting a huge noise signal. And let's see, it freezes the last one. Okay. I'm getting a huge noise signal. So just watch this. When I kill the server, okay, I kill the program, this is off, I'm going to turn it on, and boom, you see, I get a nice even DC signal, and I think you can see it in real time if I say auto. Yeah, so you see I'm seeing just a perfect 5-volt signal, but as soon as I turn that motor on, what is going to happen? I'm going to say go. You see, I get a horrible noise signal, and then I lose connection. I lose my Wi-Fi connection. Okay, and you can see why, because it is just a huge noise signal. The one thing I'm going to try is, do you see how I have both of these jumpers connected to 5 volts? Now I tried to run part of the circuit on the 5 volts over here and part on the 5 volts over here, but still the problem was that it was generating noise that was getting from here over to here. So this one, I'm going to see if I set this at 3.3 volts, because the Pi Pico only needs 3.3 volts. Will this give me some isolation? I think the motor noise is coming from here up to here, over to here, over to here. But let's see if at 3 volts, if we get a little bit better response. So I'm going to run this again. Okay. And server did not respond. Okay, that's because I didn't turn the server on. So I'll kill this. Let me turn the server on. And then we get a beautiful 3.3 volt signal. I think I can probably, yeah. You see 1, 2, 3, 3.3 volts. Beautiful signal there. I think it was better where it was. I shouldn't have messed with it. 3.3 volts. You can see that across there. Now I'm going to run the client. Okay, and let's set a little bit of a forward speed. We were setting it about there. And now when I say go, look at that. The noise is much less, and look, I'm still getting the data. Okay, I'm still getting the data. So you see I did get some noise isolation. So you see I can go slower, I can go faster, I can stop, I can reverse, and then I can come in the reverse direction. And so that is looking pretty good. Let me stop. Okay, and I lost the signal again. Okay, I lost the signal again. No, I didn't. Why is it that stop isn't working? My stop button isn't working. Okay, somehow the stop didn't do the stop. So let's look at that stop button. Red button is stop. Motor stop. Did you guys catch that? Were you screaming at me? Uppercase letter 0. Okay, so now let's try that. Server on. Okay, now it's connected to the server. We'll come to a slow speed. We'll say go. We'll say stop. We'll say reverse. We'll bring up reverse. We'll stop. We'll go. We'll stop. We'll come up higher in reverse. Faster speed. Stop. We'll come faster. Go. It's still maintaining. But do you see how as I'm going faster, my noise signal is getting worse here? My noise signal is getting worse as I brought things up. The noise is getting much, much worse. So when I played that little trick of going to 3.3 volts, that worked a little bit, but it didn't work perfectly. Now what I want to do is let's stop it. And now I want to see kind of what is happening. So I'm going to take the scope, and instead of looking at the power supply, I'm going to look at that PWM signal. Okay, I'm going to look at that PWM signal and see what's happening with the PWM signal. So now we're going to come back over here. I'm going to turn it server off, server's on. I'm going to kill the client. Okay, the server is up and running. I'm going to start the client. Okay, so now if I'm thinking about this right, if I say go and I start bringing the forward speed up, yeah, do you see I've got a beautiful PWM signal? Let's bring it on up. Beautiful. I'm still receiving data. Beautiful. Still receiving data. Okay. Now you might start seeing I'm kind of getting a little bit of some chewing on the edge of that PWM signal. Okay, it's still holding up at 71%. I'm at 84%. Okay, and then as I tried to go higher, finally I just lost my PWM signal. Do you see the PWM just kind of fell apart? And also I think what's happening is it's probably dragging that battery down. Okay, so what I think is happening, I have a noise problem, and if I try to run the motor full speed, then it's probably pulling this power supply down, and it's some combination of those two things. And so one thing that I think I will try is that I don't know if this battery is fully charged. And so what we're going to do is we're going to give it a little bit of a boost. We are going to give it a little bit of a boost. That battery is going to get a boost from our USB cable. If I can find our USB cable, where did that silly, aggravating USB cable go? Here it is. Okay, so I'm going to plug this in. Over to here. Now I'm going to turn the server on. Okay, so now I'm running off of the battery, and I'm getting some extra juice from the USB cable. Okay, so now let's run this. Let's bring this over. And so now I'm going to bring the forward speed up a little bit. I'm going to say go. And look at that. That looks nice. The PWM signal looks good. We bring it on up to 61%. USB signal is holding strong. We're up at 80. The PWM signal is looking great. PWM signal is looking great. And as I come up to 89%, I've still got a beautiful PWM signal, and then I'm still receiving data. We're up to 94%. PWM is looking great. We go up to 100%. Motor is running full speed, and the PWM signal is running fine. Now let's stop it. It stopped. Let's go a little bit in reverse. You won't see this because this is a different pin. You know, the scope isn't on the right pin to see this. But same thing, we get that strange behavior with this motor running full speed. But okay, man, guys, this is working. Okay, so what's the one little thing that I learned here? The one little thing is I think that this power board with the battery does not have enough juice to run the motor at full speed. And when we try to run it at full speed, I think maybe the motor controller and the Pico aren't getting the amount of power that they need, and that's probably what's going on. You can see that we took care of a lot of the noise problem when we moved this jumper from the 5 volts to the 3.3 volts. I think that kind of isolated the noise signal from this part of the circuit. But then the problem is, I think, as we start trying to ramp up the power, then all of a sudden we were not getting the power that we needed to the Raspberry Pi Pico W. Okay, guys, this was actually, I think this lesson was not quite as painful as the last one. I think the last lesson was particularly painful because I wasn't deliberate enough in the way that I was writing the code for the PyQt widget. I like to set up my layout, and then down here I like to stack my layout before I do any of the code in the middle. So be deliberate about your layout, define the layouts up here, stack them together down here, and then build your widgets and populate those layout boxes in the middle. And I think if you do that, that works really well. Okay, guys, I think your homework assignment is to just freestyle it for next week. I've shown you how to do PyQt. I've shown you how to have client server over Wi-Fi. I've shown you how to power your projects remotely, right? And so I just want you guys to think of all of the things. I want you guys to think of all the things that I've taught you in those first 116 lessons. And I want you to do something with a PyQt box and a Wi-Fi over UDP, and then control something from your desktop. Build a Raspberry Pi Pico project that you control from your desktop, or you get data back to your desktop from the Raspberry Pi Pico W. And right, even like you could think about the weather station, right? You could bring the weather in, and you could have like a temperature graph, you could have a humidity graph, you could make a nice little weather widget, you could control the servo with slider bars. You know, there's all types of stuff you can do. But your homework this week is to freestyle it, and let's see who comes up with the best. This would almost be, what is that? What is that nonsense? Somebody is trying to reach me, but we will deal with that later. What is this? Okay, there, I got rid of it. Okay, so that's your homework for next week. Guys, I hope that you are enjoying taking these classes as much as I am making. This is a pretty big deal, what we've just done. We've done state machines, and we've done Ethernet UDP protocol over Wi-Fi, and we've done PyQt graphical interfaces. Man, you guys have really, would you stop that and go away? You guys have really learned a lot of useful things, and I want to tell you guys goodbye, but this is really turning out to be an annoying. Okay. Anyway, grandson calling. Hi, Micah. He knows how to make a call. He doesn't know how to turn the microphone on. Micah, can you wave at me? Micah, can you wave at me? Okay, buddy. Yeah. Hi. Okay, buddy. I can't hear you. I'll talk to you later. Bye. Okay. There we go. Okay. He's going to ring back, you know it. Okay, guys, I hope you enjoyed taking these classes as much as I do making them. As always, I want to give a shout out to you guys who are standing with me on Patreon. These in-depth classes, this type of material that I am making does not get millions of views. People want the simple copy and paste stuff. These videos don't get the views. The only way that I can make them is with the support of the Patreons who are doing the advanced materials. So I want to thank you guys. You can also help me by giving me a thumbs up on the video and leaving a comment down below. When you do, make sure that you remember to subscribe to the channel. When you do, ring the bell so that you'll get notification when future lessons drop. And most importantly, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.